Today we are going to talk about air pollution and health within the theme of geography of health and well-being. Myself Dr. Netran Sahu from Department of Geography, Delhi School of Economics, University of Delhi. Let's talk about air pollution and how it influences the human health. So learners will be informed various types of air pollution and classification of air pollutions, and learners will aware about the source and characteristics of air pollution. Then learners will also understand the air pollution's impact on health and the environment, and also they will know how the measurement methods, what are the process of measurement methods and organizational control efforts and regional various types of regional case studies on pollution and its impact on human health. So outline of my lecture today is like introductions, we have then definitions, classification, features, characteristics, source of air pollutions and measurement of techniques for air pollutions, and then we have organizations working on control or monitoring of air pollutions, the various case studies, and then recommendations, summary and few good reference of books, websites and research articles. So let's start with the introductions. Air pollution is a significant environmental issue affecting health and environment worldwide, which with the major pollutants including particulate matter, we can say suspended particulate matter, which we call also PM 10, PM 2.5 like that, and gaseous pollutants and also biological molecules. So responsible for approximately 7 million premature deaths annually as per the WHO. Air pollution is cause of death. Then air pollution exaggerates extra-respiratory infections, cardiovascular disease, strokes and lung cancers, especially affecting vulnerable populations like children and the elderly. This discussion aims to define and classify air pollutions and analyze its features and source, and then explore and measurement methods highlighting the organizational control efforts. And as I have already said, we will produce here few case studies. And understanding air pollution's impact on human health and the environment aids in developing effective mitigation strategy, highlights the need for international cooperations and emphasize regional variations and high risk areas. So what is air pollution? Let's see. Like harmful and excessive quantities of substance like solid particles, for example liquid droplets, gases or in the earth's atmosphere from natural sources also like volcanic eruptions and human activities, for example industrial process, vehicular pollutions, these are also the part of the air pollutions. Then according to the World Health Organizations, air pollution is contamination of indoor and outdoor environment by any chemical, physical or biological agent that modifies the natural characteristics of the atmosphere. And then air pollution means the presence in the atmosphere of any pollutants, like we have many harmful that pollutants are harmful for the human health. Then in contemporary terms, air pollution encompasses a wide range of pollutants and their sources, which includes primary pollutants directly emitted and secondary pollutants formed in the atmosphere. So what are the classification of air pollutions? Classification of air pollutions by sources: natural sources, then we have anthropogenic sources. Within natural sources we have volcanic eruptions that emits and sulfur dioxide, particulate matter and other gases. For example, 1991 Mount Pinatubo of Philippines eruptions impacted global climate and air quality. And then we have wildfires also, like produce particulate matter, carbon dioxide monoxides, volatile organic compounds. And examples are like wildlife or wild fires in California and Australia affect extensive air quality. So these wildfires also, because of the getting fire in the forest, that is also very dangerous and that also enhance the air quality. Then we have dust storms like transports. These are particulate matter over long distances. Examples are like Saharan dust storms impact air quality in the Caribbean and Americas. Then biogenic emissions from the vegetations and soil, for example isoprene or methane. Then we have anthropogenic, like how the human activities also influence this air quality, and within that like we have anthropogenic sources like industrial activities, transportations, agricultural activities and residential heating and cooking. So then if you see like classification by pollutant types, like particulate pollutants, then particulate matter includes PM10 and PM2.5 that comes from the constructions of and road dust and combustions of vehicular pollutions. Then black carbon, a component of PM2.5 from incomplete combustion of fossil fuels and biomasses. Then gaseous pollutants, the ozone is one of the gaseous pollutants, that secondary pollutants from nitrous oxides and also VOC and reacting in sunlight and major smoke components. Then carbon monoxides, then from incomplete combustions of air contaminating fuels and impairs oxygen deliveries. Then we have sulfur dioxides. Sulfur dioxide is from burning sulfur containing fossil fuels, and this causes also respiratory problems and acid rains. Then we have nitrogen oxides. Nitrogen oxides basically includes nitrogen oxides and nitrogen dioxides from vehicles and power plants and industrial processes. Then we have VOC, that is volatile organic compounds. Then it includes benzene, toluene, xylene from the industrial process and vehicular emissions. Then we have also another factors like classification by health and environmental impact. So health impacts like carcinogenic or carcinogens, you can say benzene, formaldehyde, asbests increase cancer and also various other diseases. And then respiratory irritants like nitrogen dioxides, sulfur dioxides, ozone, and that causes also like respiratory problems like asthma and also reduce the lung functions. Then cardiovascular effects like PM2.5 linked to heart attacks and strokes. We have another component like environmental impacts. So like acid rain produces for example sulfur dioxide, nitrogen oxides transform into acids, causing acid rain that damage ecosystems. And we have climate forces, then carbon dioxides and also methane and black carbon contribute to global warming and climate change. And eutrophication agents, and that is airborne nitrogen compounds deposit into water bodies and causing nutrient overloaded. So then classifications by geographical distribution and regulatory frameworks. Geographical distributions, you can say urban areas or rural areas basically. In the urban areas, because of high pollution, industrial establishment, high population density, and that's why for example we have Beijing and China's capital, and also Delhi we have in India also facing these problems. Then rural areas affected by agricultural activities, biomass and also burning of different types of fossil fuels, and also like stubble burning. So transboundary regions, like we have pollutions travel across borders, that is also another factor. Then regulatory frameworks, like India's within regulatory frameworks we have various how these regulatory frameworks are controlling, like India's CPCB, Central Pollution Control Board, and we have that is giving like set of standards of national ambient air quality data, basically PM10 and PM2.5 and PM. Then also we have sulfur dioxides and ozones, the data basically provided by the CPCB, Central Pollution Control Board. And we have Geneva Convention on long range transboundary air pollutions, that is addresses the regional air pollutions. Then we have Paris agreements also, where targets greenhouse gas emissions reductions, indirectly addressing air pollutions. Then we have classification by geographical distribution and regulatory. After that also we have another factors like features of air pollutions. What are the features? That is physical and chemical properties of air pollutants. So what particulate matter, for example, what are the physical properties? That means mixtures of solid particles and liquid droplets, and also size range like PM10, PM2.5 and PM0.1. Then we have chemical properties. Within the chemical properties, that is composed of sulfates, nitrates, ammonium and black carbons. And we have also like you can say gaseous pollutants like ozone, we have already said, and then sulfur dioxides, SO2, and nitrogen dioxides and NO2, then carbon monoxide. These are also giving various types of creating health impacts on humans. So then distribution of air pollutants. Distributions like special distributions, as we have already said, urban area and rural areas, and then temporary distributions, seasonal variations, then diurnal variations and meteorological influences. What are the seasonal variations? Like high PM level during winter, it is happening. For example, we have in Delhi, higher pollution is there during winter. And then diurnal variations like ozone levels peak in the afternoon and due to sunlight. So then we have meteorological influences, that is wind disperse dispense pollutants, and temperature inversions trap the pollutants. So that is the way also we are measuring how these pollutants are coming. So then this characteristics of air pollutions. Within the characteristics of air pollutions, we have persistence in the environment, like persistent organic pollutants. For example, examples are dioxins and polychlorinated biophenyls, then DDT, which is known as dichloro diphenyl trichloroethane, and characteristics are like persist long term, bioaccumulate, and travel long distances. So then also heavy metal in the persistence of environment characteristics. Then we have heavy metals, for example lead and mercury and cadmium. These are also like characteristics, do not degrade, accumulate as solid or like sediments, and long term contaminations. This also sometimes lead contaminated water also underground level. So then we have greenhouse gases, like examples are carbon dioxide, methane, and nitrogen oxides. Then we have these are long atmospheric lifetimes, like decades to centuries, significant contributors to the global warming. So then ability to travel long distances, like characteristics of air pollution, that is ability to travel long distances. Within that, for example, transboundary pollutions. Examples, European industrial emissions affecting Scandinavian, for example. Then atmospheric transport, like Saharan dust storms reaching to the Caribbean or United States. Then global circulations, we have like examples of carbon dioxide mixing uniformly worldwide, contributing to the global greenhouse gas. Then environmental fat and transport of air pollutants, like chemical transformations, example nitrous oxides reacting to VOCs to form ozone, and sulfur dioxide oxidizing to form sulfur aerosols. So then deposition process, for example we have wet depositions, like pollutants removed by rain or snow. Then we have dry decompositions or dry depositions, that is particles and gases settling on soil, vegetations, and water bodies. So then absorptions and disruptions, or you can say for example here in this case absorptions and adsorptions. So here absorptions, like carbon dioxide absorbed by oceans and plants during photosynthesis, and also adsorptions, like heavy metals adsorbs onto soil particles, leading to soil contaminations. Then source of air pollutions, we have natural sources of air pollutions, like volcanic eruptions, and then wildfires, then dust storms, and also biogenic emissions. Then what are the sources of within that? We have anthropogenic sources, like industrial activities, and also we have example of high levels of industrial air pollution in China, USA, Europe, and India. So India, for example, we have various mega cities, like we have also Delhi is one of the best example where we can see, because of this serious anthropogenic impact, pollution level is too high. Then transportations, like burning of fossil fuels in the vehicles produce carbon monoxide, nitrous oxides, and particulate matter, and hydrocarbons. Okay, examples are severe air pollutions in urban areas like Los Angeles and also in Beijing, and also we have in India Delhi, Kanpur, like cities. So then agricultural activities, use of fertilizers and pesticides release ammonia and other chemicals, like they are impacting livestock farming, produces methane also, and also nitrous oxides. Examples are like agricultural burning in India contributes to a significant air pollutions in the Delhi, for example stubble burning. Then we have residential heating and cooking. So the within the households, the burning of solid fuels like coal, wood, and biomasses in households emits particulate matter and carbon monoxides. And examples are major source of indoor and air pollutions in rural or and low income areas. Then indoor air pollution or combustion sources, indoor burning of cooking, heating, and lighting procedures, carbon monoxide, particulate matter, nitrous oxides, and VOCs. And examples are traditional stoves and open fires in developing countries. Then we have building materials and furnishings. Then for example emit VOCs and other chemicals from paints and varnishes, and also cleaning agents. Example, formaldehyde for materials like plywood and particle board. So they are also creating environmental pollutions. Then biogenic pollutants, you can say biological pollutants. Within the biological pollutants we have like include mold, dust mites and pet dander and pollens, and these are also indoor allergens worsening asthma and allergies. So, and another component is radon, like radioactive gas that accumulates in the buildings and also significant cause of lung cancer in the non-smokers. So, then we have examples of some major source of air pollutions like industrial air pollution in China. For example, you can give severe air pollution from coal fired power plants and manufacturing in the cities like Beijing. We have vehicular emissions in Los Angeles, even high levels of nitrous oxide, carbon monoxide and particulate matter from vehicle emissions, and we have agricultural pollutions in India like significant emissions of ammonia, methane and particulate matter from fertilizers, pesticides and crop residues burnings. So, understanding the various sources of air pollution is essential for developing effective migration strategies, and natural sources such as volcanic eruptions, wildfires contribute to background levels of pollutants, and also we have while anthropogenic activities like industrial processes, transportations and agriculture are major source of harmful emissions, and indoor air pollutions poses significant health risks, particularly in households relying on traditional fuels, and addressing these sources requires a combination of regulatory measures, technological innovations and public awareness campaigns. So, then we have measurement of air pollution levels like monitoring technology for air pollutions like ground based monitoring stations, and then we have continuous emission monitoring systems like measuring pollutants emissions at industrial facilities, and air quality monitoring networks provides regional data on air quality, track trends and also issue related to health advisories. So, here another factor which is very important to see also trace or measurement of these techniques, we can have remote sensing like NASA's Aura satellite that monitors global air quality and atmospheric compositions. Then we have Copernicus Sentinel 5 that provides high resolution data on atmospheric gas and aerosols. Then we have portable and low cost sensors, that is personal air quality monitors, wearable devices for tracking personal exposures to pollutants like PM 2.5 and PM carbon monoxide etc. Then community monitoring projects like deploy low cost sensors in communities to collect local air quality data. So, then within the measurement techniques we have sampling methods for air pollutions like active sampling, use a pump to draw air through a filter or collection of medium. Then we have gravimetric methods like measuring particulate matter by collecting and weighing particles on a filter. So, then gas samplings like captures gaseous pollutants, sulfur dioxide, VOC and NO like nitrous oxides using absorption or adsorption media. So, then passive sampling like relies on natural diffusions of pollutants to a collection medium. So, then we have diffusion tube like contain chemical absorptions for long term monitoring of carbon dioxide and ozone and nitrogen dioxides. Then we have base samplers, wearable devices for personal exposures monitoring in occupational health studies. So, then we have data integrations, modeling and future directions. Data integrations, how you collect the data and how you integrate for different types of analysis so that you can frame a policy. So, for that matter combines data from ground based monitors and satellite observations and portable sensors, and then hybrid monitoring networks for example integrate multiple data sources for detailed air quality informations. Then we have air quality modeling, and within that like chemical transport models we have simulate chemical and physical processes affecting air pollutants, and this dispersion models then it predicts spread of pollutants from specific sources. So, then we have changes and future directions. Within the challenges what are you are going to say, for example ensuring data quality and expanding spatial coverage and improving temporal resolutions. How you can come down to even you can have hourly or minute or half hourly data, and you can have also expand the spatial coverage. For example, in whole India or the within million plus city if you want to see the air quality, then we have to cover all these areas, and also some like apart from million plus cities, some other cities also we can cover where air pollution is otherwise also very high. So then future directions like technological innovations, advances in sensor technology, data analytics and machine learnings, and then integrated monitoring systems like combining ground based satellite and low cost sensor data, and also like community engagements like involving communities in monitoring effects and advocacy of cleaner air. So within this also we have different types of how the use of other like techniques, different types of various organizations they are working to control air pollutions, or ministries we can say. We have non-government organizations, they are also working nationally, internationally. So we have many such bodies, those are organizations, they are working for this monitoring of air pollutions. For example, global organizations, we have World Health Organizations provides global air quality guidelines and also conducts global assessment of air quality and health impacts on various types of environmental issues. Examples: WHO guidelines help countries set air quality standards to protect public health for their respective countries. United Nations framework programs, it is like coordinates environmental activities, supports developing countries, and also initiatives like climate and cleaner air coalitions reduce short-lived climate pollutants. Then also like UNEP, global environmental outlook reports inform sustainable policy decisions. You know, the United Nations Environment Program that's headquartered at Nairobi, Kenya, is providing this like outlook reports to inform the sustainable policy decisions that caused because of these air pollutions. Then World Bank, we have like World Banks like offers financial and technical assistance for air quality improvement projects. For example, pollution management and environmental health programs helps countries implement pollution control measures and cleaner and clean technologies. And other organizations for that matter is Indian organization and ministries working on this air pollution or controlling or monitoring, like Ministry of Environment, Forest and Climate Change at the central level. So responsible for planning and promoting environmental programs like key initiative National Clean Air Programs, then aims to reduce PM 2.5 and PM 10 levels by 2030. And okay, like control that targets reduction of up to 20 to 30% by 2024. So then Central Pollution Control Board like monitors air quality and enforce pollution control regulations, and key initiative are like national air monitoring programs tracks the air quality across India. So then we have like Ministry of Road Transport and Highways, and this is like implements policy to reduce vehicular pollutions. And also for example like we have a key initiative of Bharat Gas emission standards regulate the vehicular emissions. Then Ministry of Power we have, within that also promotes clean energy and energy efficiency, and like these key initiative are perform, achieve and trade like part perform, achieve and trade scheme aims to improve energy efficiency in large industries. Then also non-government organizations like the Energy and Resource Institute TERI conducts research and promote sustainable development practices. Key initiative like Clean Air Project in India, and also focuses on improving air quality through various interventions and public awareness camps across different parts of the city in Delhi, also in other parts in India. Center for Science and Environment, which is another very famous organization, non-government organization working on the air pollutions and the different environmental issues, and that conducts research and publish reports and advocacy of police changes. Then Clean Air Asia, Clean Air Asia is like works on to improve urban air quality through sustainable development and implements projects and raise public awareness with the various stakeholders. Then we have Clean Air Task Force. This is promotes the policy to reduce emissions from power plants, industry sources and also transportations. Then air pollution case studies, we have case studies like in Delhi, always we have a very critical problems in Delhi air pollutions. You might have seen this through different media, different print media, electronic media, and there are many issues: severe air pollution from vehicular emissions, industrial activities and construction of activities and agricultural burning. This pollution level is so high. Then interventions like graded response action plan, and we have odd even schemes for like vehicular to reduce the vehicular pollutions. Then promotion of public transportation systems like DMRC, Delhi Metro Corporations. They are now expanding their base to all the parts of the Delhi, and also NCR, that will reduce the and also ban on firecrackers during Diwali, and we have outcomes like temporary reductions in the pollution levels. So then we have another case study in Beijing, like China. They are background severe air pollution from industrialized and vehicular emissions, and also coal burning. And so interventions like air pollution action plan, they are a comprehensive measure to reduce coal burning and also control vehicular emissions, relocate industries and various parts, other parts, and then reduction of coal in the burning process, like shifting to natural gases. Then also vehicular emission standards, they have also their fixed vehicular like we have Bharat vehicular emission norms, they have their own norms, and also they are going for hybrid mode, electric and other modes of transportation systems. Then the outcomes like significant improvement in the air quality reduction of PM 2.5 levels, and challenge remain especially during winter cool and also other winter and heating periods. Then another third case study is from Los Angeles, USA, and historically the air pollution due to populations and traffic and industry. This contributes more in Los Angeles, and geographic and meteorological factors also contribute to smog formations in that area. So then also the interventions like they are working on the clean air action plan and focusing on reducing the emissions from transportations and port operations and also industries, and also Port of Los Angeles clean air action plan. Within the Los Angeles port, they are trying to reduce and targeted the cleaner fuels, so that they will have zero emission technology are implementing, and vehicular emission standards like strict regulations of promoting to electrical vehicles, and also outcomes like decrease level of nitrogen oxide, particulate matter, and all this. So we have lessons learned, recommendations like integrated approach, and then public transportation and clean energy, enhancing public awareness, international cooperation and research innovations. For this outcome is, we can say, the multifaceted nature and of air pollution requires a holistic approach that integrates scientific research and stringent regulations, technological advancement and public engagements. And another issue, very thing we learn from here, like addressing air pollution is not only a matter of environmental protections, but also a crucial step towards safeguarding public health and ensuring sustainable development. The outcomes of these discussions highlight the urgent need for concerted efforts to mitigate air pollutants. And so here for this lecture I have some references like few books recently available, and you can also buy these books from the link or to download. And then we have few journal articles, they are talking about this air pollution and their impact on the human health, as you know. And also we have very provide here, I have tried to provide here some websites where you can see the government report and policy documents and various institutions reports. Thank you.